Okay, here we go with Chapter 1 review for our first test. The test will consist of multiple choice as well as short answer and completion. What you should study besides the review is your notes, including any left side activities we did or any journal questions that we did that pertain to the chapter. All right, so let's get started. So this first section says classify each of the following as a homogeneous or heterogeneous substance. And so in this case, it means the whole thing, not just if it's a mixture. I'm going to be abbreviating homogeneous as HM and heterogeneous as HT. Now, I want to make sure you understand that this substance word right here is a little bit different than a mixture, because compounds and elements are also homogeneous in that they look the same throughout, but they are not mixtures. So I'll make sure you don't get confused by that. So let's go with sugar. And we, of course, know that sugar is a compound because I gave you that formula in class. And so a compound is going to look the same throughout, so it would be homogeneous substance. Iron filings, we had that in our classifying matter, I believe, activity, and that is an element because iron is an element. And of course, elements look the same throughout, so that's going to be a homogeneous substance. A granola bar, obviously, if it's got chocolate chips or raisins or whatever, it's going to look differently all throughout. So that's going to be a heterogeneous substance, but this would be a heterogeneous mixture. Okay. And then the plastic wrap, that means like saran wrap. If you look at that, it looks the same throughout. It would be, we would actually call that a solution because it does look the same throughout. And so that would be a homogeneous substance. And then lastly, we have cement. And if you look at cement, it does look different. You've usually got little rocks or pebbles in there. We would call that a suspension. And so because it's a suspension, it would be heterogeneous throughout, meaning it would look different. All right, let's move on to the next slide. For this section, we're going to say whether each one of these things is either basic research, applied research, or technological development. And in some cases, more than one choice may apply. So the first one is a university plans to map all the genes of a human chromosome. And of course, they were, in that case, they're trying to just be basic research. So they're just trying to find out all the genes on the human chromosome. The next one says a research team intends to find out why a lake remains polluted to try to find a way to clean it up. And that's going to actually be both applied for the why it's being polluted, but it would be technological for finding ways to clean it up. C, a science teacher looking for a solvent that will allow graffiti to be easily removed. That would be applied because remember that is when you're trying to solve a specific problem. And then cancer research wants to know the chemistry of the cell. That would be basic because it's broad in scope. So this one is wanting you to use the periodic table to define the name, group number, and period number of the following elements. And hopefully you watched your video lesson. That's where you would be able to find this from. Chlorine is the first one. Cl is chlorine. And if you look on the periodic table, that would come from group 17 and period 3. So I'm going to go ahead and pause the video and let you look those up, and then we'll come back together and see if you got them all. So here we go. Hopefully you got those correct with the group numbers and the period numbers. It's literally just looking them up on your periodic table. You will have a periodic table for the test. As a matter of fact, you get a periodic table on just about every test throughout the year. Just remember that sometimes we get confused on test, and that group numbers are what goes up and down, and period numbers go side to side, okay? And so let's move on to the next slide. So question 5 is what is the difference between extensive and intensive properties? And remember that they are, they're both physical properties. So extensive depends on the amount of material or the amount of substance present. So that's things like mass and volume. And then intensive depends on, of course, the identity, not the amount. So that's things like density and boiling point. And we talked about that in class For instance, the boiling point of water is 100 degrees Celsius. It does not matter whether I have a cup full of water, a pot full of water, or a lake full of water. The boiling point is always 100 degrees Celsius because that is one of the identifying properties of water. All right, let's go on to the next one. Question 6 wants to know if burning gasoline or evaporating gasoline, it wants you to classify which one is a chemical or which one is a physical change. And burning is a chemical change because a new substance is being created. In this case, when we burn gasoline, we're creating water vapor and carbon dioxide, which are new substances from the gasoline. And then evaporation is, of course, remember we talked about a phase change, whether it's changing between its liquid, solid, or gas form, is always a physical change because we're not creating a new substance. We're just changing the form of liquid gasoline into gasoline vapor. And so the gasoline is still there, so it would be a physical change. So question 7 asks us to construct a concept map that includes those following terms. And so basically what you're going to be creating here is the matter flow chart. And so if you have not done that, you should pause the video and see what you come up with, and then start the video again and see how you did. Okay, let me first apologize for how messy this is. It's kind of hard to do on the iPad, but here's our matter flow chart. We have matter. We have to ask ourselves, can it be separated by physical means? If the answer is yes, we go over here to mixture. And then once we know it's a mixture, we have to ask ourselves, is it uniform in composition, meaning does it look the same throughout? And if the answer is yes, it does look the same throughout, then we say it's a homogeneous mixture, or we also call those solutions. If it is not uniform in composition, then we say no, and we go over here to heterogeneous mixture. Remember, we also have solutions and colloids underneath there, but this did not ask for that in the question. If the answer to the question of separated by physical means was no, then we go over here and we say we have a pure substance. And then, of course, we ask ourselves after that, can it be chemically decomposed? If the answer is yes, we know we have a compound. Remember, a compound is made up of 2 or more atoms from the elements that are chemically combined. If the answer to the chemically decomposed was no, then we know we have an element. And remember, an element is all the same kind of only one kind of atom. Okay? If I were you, I would look at the matter flow chart in our notes. It probably is less messy than mine, and it explains it a little bit more extensively. Okay, so this next question says know the definitions. They are in your notes. I cut and pasted them from your notes. So make sure you look over that and understand these definitions and move on to the next slide, which is more definitions. Here are some more of those definitions. So just make sure you're reading over these as well, and then go to the next slide. So here we have some examples of the types of matter. You need to make sure you understand how to classify matter and know whether it's an element, compound, homogeneous mixtures, which we called solutions, or a heterogeneous mixture, which could consist of colloids and suspensions. So I've listed a few here just so you can kind of notice. Remember, if it's an element, it's going to be found on the periodic table. If it's not on the periodic table, it is not an element, so don't say that it is. Compounds tend to have a formula, or actually not tend to, they do have a formula. And these are some examples we used in class. And of course, homogeneous mixtures, which are solutions, remember they look the same throughout. They have a uniform composition. So don't get caught up in the fact that it's just going to be a solid dissolved in a liquid. You got to remember it can be gases like air, or it can be solids like in the case of alloys, which brass and bronze would be an example. We did a journal question and we asked about stainless steel, and that was, we said, was also a solution. And of course, the heterogeneous mixtures, they have a non-uniform composition, meaning they look different. You can visibly distinguish their parts. And so there's some examples there as well. And then, of course, fog and shaving cream would be the colloid part. Anytime we're looking at a chemical equation, which in chemistry we obviously will be looking at lots, you always need to understand that the reactants come before the arrow and the products come after. Think of it this way, the two things have to react to form something new or to produce something new. So it's always reactants yields products. So here let's talk about the four states of matter and how we can identify them based on their shape, volume, and particle placement. So let's start with solids. First of all, solids have a very low kinetic energy. Their particles are very orderly. They vibrate in place, so they cannot move around, but they do vibrate in place. And of course, solids have a definite shape and volume. Excuse me. Liquids also have a low kinetic energy. Their particles are close together, but they can move, and we think of them as sliding over each other, and that's why they have that ability to flow, is because they can slide over each other. They have a definite volume, but they have a variable shape, and remember, they take the shape of their container. Gases have a high kinetic energy. Their particles are far apart. They move freely. They are highly compressible, meaning I can push them together, and they have a variable shape and a variable volume. And then lastly, the fourth state of matter is plasma, which has a very high kinetic energy. Remember, the particles are colliding with enough energy that they break apart into ionized particles or charged particles, and they are in fact the most abundant form of matter. Okay, so we know from our flipped lesson, we have to know the basic parts of the periodic table and know the properties of the metals, nonmetals, and metalloids. So here's the periodic table that we had in our notes that we did in our flipped lesson. Remember, the groups go up and down. So group, 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 all the way up and down, up and down, up and down. And then the periods go side to side. So these are the periods. All of the metals are on the left-hand side of the table. It's this little zigzag line. Everything over here is metals, with the exception of hydrogen. It's over there by itself, but it is a non-metal. If it's touching the line, with the exception of aluminum, then it is a metalloid. And then, of course, if it is on the right side of that zigzag line, it is a non-metal. The ones that are starred are gases. The two that are circled are liquids. Everything else is a solid. Let's go on to the next one and talk about the properties of metals, nonmetals, and metalloids. So the last thing is the properties of metals, nonmetals, and metalloids, and this was again from the flipped lesson. The properties of metals, remember that they are good conductors, meaning they conduct electric current and heat. They are malleable, which means they have the ability to be hammered into a thin sheet. They are ductile, which means we can pull them into a thin wire. They're shiny, or we also sometimes call that luster, and they have a very high boiling point. Nonmetals are basically the opposite. They are poor or non-conductors. They are not malleable. Matter of fact, they're very brittle. They break very easily, and they have a low boiling point. Many of them are gases, but they can be, a few of them are liquids and solids, but most of them tend to be gases. And then, and the metals, of course, are all solids except for mercury. And then the last one is metalloids, and remember they're on that zigzag line on the periodic table, and they're kind of like between. That's why they're a metalloid. They're between. They have some of the qualities of metals, and they have some of the qualities of nonmetals. They are semiconductors, which is why they're used in a lot of electronics, especially silicon, is used in a lot of your iPhones and iPads. They are slightly malleable, and they are somewhat brittle, and they have an intermediate boiling point, and they tend to be solids. All right, stay tuned for the next slide for the jokes.
All right, let's end the review with our jokes, as promised. Number 1, why was school so easy for the cave people? Because there was no history. What's the best thing about living in Switzerland? Well, the flag's a big plus. All right, don't forget to study your notes, your worksheets, and the review.